Hey everybody, it's Mrs. Bianchi. We're taking a look at question 1A and 1B, which is the same question, but there's different parts to it. It says Ashley is bagging 32 pumpkin muffins and 28 banana muffins for some friends. Each bag will hold only one type of muffin. Each bag will hold the same number of muffins. What is the greatest number of muffins she can put in each bag? And then the second part of this question is how many bags of each type of muffin will there be? So I'm going to put this on Smart Notebook software so we can take a look at it. Let's look at the evidence that we're going to be applying the GCF. So that's the idea that we need to first find the GCF and then know to use the distributive property. Something plus something. All right, so the evidence that we need to set it up this way. There's two pieces of evidence. First piece of evidence is it says, what is the greatest number of muffins? So when you see greatest number of, that's when you know you have to find the GCF. Now, the answer to the question, how do you know when you're also applying distributive property? It's when you see same number of in the word problem. So we see that here, which means we jump into distributive property mode. All right, so we do have to find the GCF of the two numbers in the problem, which are 32 and 28. Let's write those numbers down. 32 and 28. 32 and 28. Draw a line to separate your workspace. All right, so when you start doing your factor trees, you want to try to use the number that you suspect as being the GCF. So let's say you think the GCF is 4. Put the number 4 in both factor trees. So I'm going to put the 4 over here. I'm going to put the 4 over here. All right. Now let's finish with the 32. I'm going to move. I have my circles already ready to go here, but it looks like they're going to be in the way. So let me move these down just a bit. All right. Let's go back to the work. 4 times what would be 32? And the answer to that question is 4 times 8. Let's use green. Now, both of these are composite numbers, so we're going to keep branching. Now, later it'll become more clear why I'm choosing to write 4 in red font and the other factors in green font. What times 4 equals 28? That would be 7. Now, these are both composite numbers, so we have to keep branching. We'll keep branching on the 4 and get the 2. And here we would say 4 times, move that out of the way, 4 times 2 would equal 8. And we have to keep branching. This is composite. Keep going. And then bring everything else down. So we have this 2 here. And then we have this 2, which I'm going to leave in red font for a reason that'll become more clear later. And then I'm going to bring this 2 down. All right, so this prime factorization is done for 32. Let's move on to the prime factorization of 28. We're not finished with this tree yet because 4 is a composite number. We're going to keep branching. 2 times 2 would equal 4, and then we have to bring down the 7. All right, so once you have your prime factorizations done, now it's time to organize it. So for 32, we'll have this circle represent 32. We'll have the other circle represent the other number, which is 28. And we'll look for matches. So what's a match that's in both prime factorizations? Let's separate with the line. All right, so we have matching 2's. Here's a pair of 2's. We're going to write it down. And then we have another match, right? Here's a match, this and this match. So we're going to write that down as well. And we don't have any other matches. So if we were interested in finding the LCM, then we would write these numbers, the 2, and the 2 over here, and we'd multiply that in. And we'd take the 7 over here and put this here. But we're interested in the GCF, so that means that these two numbers, when you multiply them together, will be the GCF. So if we take the 2 and multiply it by 2, we're going to get 4. So the GCF is 4. All right, now that's the number we're going to use right here. All right, now before you go any further, it's always a good idea to look back at the words that say greatest number of and figure out what would be the label on that. So let's look at the label. Greatest number of muffins she can put in each bag. Now, whenever you write a number down here and write the number GCF, you should look for something per something. Something per something. Because there's usually going to be 2 units. And what are the units? It's muffins per bag, per one bag. So I'm just going to put M for muffins and B for per bag. So that's 4 muffins per bag. All right, so now the next step is to label here with the words that we're looking at that differentiates how these muffins are different from these muffins. So we're looking at pumpkin muffins. I'll use a P for pumpkin, and banana muffins. So I'm going to put a B for banana muffins. All right, now usually what you have after the word per, which in this case is bags, usually that's what the unit is going to be on this number as well. So let's move that number over here, or I mean that word rather over here. So this is going to be bags of pumpkin muffins, and this is going to be bags of banana muffins. All right, so the next step is to figure out 4 times what would give us this 32 pumpkin muffins. And the answer to that question is 8, right? 4 times 8 would give us this number. 4 times what would give us 28? 4 times what? And wouldn't that be 7? All right, now here's the part that a lot of people mess up. The reason why you have to label everything is because that's going to help you distinguish which number applies to what muffin. So let's review. What's the greatest number of muffins she can put in each bag? It's going to be 4 muffins per bag. That's the first part. 1B asks, how many bags of each type of muffins will there be? Here's where you have to pay close attention because the numbers could be reversed. We need 8 bags of the pumpkin, and we need 7 bags of the banana. Make sure that you're paying attention to which is which. All right, hopefully you found that helpful.